I love questions. So anything comes to your mind, please. The more interactive this is, the more fun it is for me, certainly. And we'll get the conversation going in a direction that I think will all be rewarding for all of us. The talk sort of has two parts. I'm first going to talk a little bit about our software and technology, and then talk a little bit more about the company and team. And for the software technology side, I'm focusing on building a programmable network operating system. What I mean by programmable is that customers can add their own software to our switches. Now, you go to a typical Fortune 100 CIO and say, hey, did you know any of your network engineers can just download anything they feel like from the internet and run it right there on your mission critical infrastructure? And the reaction is, wow, that's really interesting. How do I turn that off? Right? So clearly this is not for everybody. But you know, the way this came about, well, it's actually been very interesting where this has been beneficial. So let me actually just sort of launch into the slides here. If you, do we want to just, is there a way I can get rid of this stuff at the top? David, do you know where this is coming from or how I can? Sorry, guys. Maybe under more. Oh, it was went way on its own. All right, great. So, so if you look at the sort of history of switch software, network switches, things started off pretty dismal. The basic notion was, well, this is just a fixed function appliance, kind of like a microwave oven, you know. So the software can be pretty simple. It's really just a control program. And the control program got bigger and bigger and bigger until you're in the situation where there's a ton of software in there. Whenever the slightest thing goes wrong in any one part of it, the entire thing crashes and reboots. And this was really just not good enough. And eventually people discovered somewhere around 1990 that there was this thing called Unix that like doesn't have this problem. And so people started building their network operating systems a little differently on top of a Unix, BSD, or Linux, or QNX, or whatever it is, kind of base. But there was still this notion that this is kind of a different kind of thing. This is just a, you know, it's just a networking device, and so the software should be real time, or sort of somehow not just like another server. And this leads to all kinds of, you know, sort of badness in my view as a software developer when you run your software without compiling it for some cross environment to some cross operating system, waiting for the thing to boot. 20 minutes later, it finally starts going, runs for 4 seconds, then crashes in some part of the code you've never heard of, and you just sort of want to find another job. So that's actually what I did. We started Arista in 2004, bringing kind of an unusual group of people together to tackle the problem. And a bunch of us were kind of good academic background, so PhDs, mainly from David Sheraton's research group at Stanford, Distributed Systems Group. So a solid theoretical foundation in distributed systems and object-oriented programming, programming languages, networking, and operating systems. But usually, if you take a team of academics and they do a company, you end up with a very interesting product. Not something that anybody's going to buy or deploy, but very interesting. But we actually had a different experience because our previous company, Granite Systems, was acquired by Cisco in 1996. And we went on there to build the Catalyst 4000 line of switches. So if you've ever bumped into the 4500 or 4900M or 4948, those all came from our group at Cisco. So we actually had lived through the realities of what does it take to, for example, ship 2 switches to every Walmart in the United States. So we lived through it and knew what the kind of real requirements were. So we started Arista determined to build the software in a different way, in a way that really took the lessons of Unix to heart, that you want to keep your hands out of the kernel. First rule of the kernel is you don't touch it, you don't break it. You want to run the same Unix on your target as on your host. Unix has always been a self-hosted development model, so you can compile just part of your software, run it in isolation, right there on your dev machine, so much more efficient, right? And then preserving our connection to the community by not hacking. So you know, when some of our competitors, they take the open source software and then they just do something like really drastic to it, like hack out the entire networking stack and replace it with some homegrown stack from some other product line. And it's not like they're dumb, right? Like there's reasons to do this. It's just that I don't think they fully internalize the cost of this. That when you make a change that big to your Linux environment, it's not really Linux anymore. Like you can't just run ordinary Linux software anymore. You can't run the same software on your development systems as on your target. So we tried to do Linux right. because you just don't get that many chances in your life to create a new commercially viable switch operating system from scratch. So you better make the most of it, right? So that's what we tried to do, which is the switch is just a Linux box. If you open up our switch, so on the outside, the switch looks and feels just like any other network switch you might be familiar with. Familiar CLI, familiar SNMP stack. You can treat it just like any other switch and you'll be just fine. But if you want to, we leave the door open. You can pop the hood. And what you're going to see inside is just a Linux server with a off-the-shelf silicon switch chip on PCI bus, forwarding packets at terabits per second, running standard open source Linux with a bunch of our software, providing the control plane and management plane and sort of driver functionality to drive the switching hardware. So this approach enables programmability, and it lets you sort of build out the feature set with a combination of open source tools and your own proprietary software in a way where each process is strongly isolated from all the others. But strong isolation is kind of an interesting property because it kind of cuts both ways. It's great from the point of view of tolerating failure. If one process has a problem, you can restart that one process, the rest of the switch keeps going. That part's great. The challenge of dividing your system into lots of processes is they're actually working together to try to achieve a goal. How do you coordinate them? And we found that these sort of traditional Linux mechanisms for this just felt inadequate. Like if you think about how HTTPD talks to our syslogd, right? Web request comes in, you write a little message to devlog. Our syslogd picks it up and syslogs it. It's all great. Unless our syslogd is having a bad day, in which case your web server process tries to write to devlog and gets back -1, and the syslog library says, oh, that's too bad, and just keeps going, right? And so you drop the log message on the floor, and for most part, that's fine. We're talking about syslog here, it's no big deal. But imagine explaining to to AT&T, you just melted down their network because a link went down, but you kind of dropped the link down because some socket was full at the time it went down, and so the routing protocol didn't do the right thing, started black holing mountains of traffic. Like, it's just not good enough, right? You want reliable multi-process. How do you couple these processes together? And so the fundamental architectural direction here is to start with, as I mentioned before, the unmodified Linux kernel, and then to coordinate the processes through a central state database, a sysdb. Sysdb is a database in the sense that its only job is to hold state, validate updates to that state, and make those updates visible to other processes running on the box. It doesn't know anything about the features. It doesn't know spanning tree from ACLs, from interface counters. It's just all data to sysdb. That said, it's about as far as you can possibly get from Oracle and still call yourself a database, because it's not persistent, it's not transactional, it's not query-based, it's not SQL-based, there's no joins, it's sort of hierarchical, object-oriented, all in memory, with notifications, and no queries at all. But it's still a database in that key sense that I articulated a second ago. And then around our system database, we put a constellation of processes providing the sort of data plane or device plane, layer 2, layer 3 control planes, and all the management software up on top of that. And to give a sense for how the system works, imagine that a link goes down, and that goes to the Linux kernel. There's an interrupt. And then there's a kernel module called UIO, the user space IO module, that converts, among other things, it converts PCI interrupts into Unix signals. And so, because we didn't want to put our ASIC driver in the kernel. It's like, drivers in the kernel is actually not really a very good idea. Like, I don't understand why the industry has gone so long. Like, I get it if you're trying to do like, DMA for your file system or whatever, there's performance concerns. But like for all this sort of low speed stuff, I don't understand why all the drivers are in the kernel, quite frankly. And so we took ours out of the kernel and said, wait, low speed, didn't you say terabits? Well, it's terabits through the switch, not necessarily to the CPU, right? So there's actually no reason for our driver to be in the kernel there. So we've taken it up into user space, and so the kernel sends our process a signal when the hardware raises an interrupt. The ASIC driver then reads the hardware and recognizes a link went down, and then updates an object in its own address space saying the link status is now linked down. And that triggers a message. Our middleware sends a message to the system database, which validates that update, makes sure the ASIC driver is allowed to write that object, for example, that the value is a valid value. You can't know if it's the correct value or not, but link could be up, link could be down. It can't be green, right? So you can shut the thing down if it does something illegal. Then sysdb propagates the update to all the processes that are interested in link down, which is pretty much the entire box, right? So, you know, our spanning tree protocol or LACP wants to withdraw the port from the topology. CLI shows the link as down, SNMP sends its trap, and GateD withdraws routes. And even our humble LED agent, the process whose only job is to keep all those little lights on the front the right color. There is, from unplugging the port to like having the LED turn off, there are more lines of software than you can even believe. But the LED agent will respond to the link down update by turning off the link LED. And the reason why the state model is so effective is it doesn't actually matter while this is happening. One thing that's kind of fun to do on our switch, and if you have one in your hands, I actually recommend trying this. Find the LED agent, just get a shell. So go to the CLI, just type bash, you've got your shell. Find the LED agent and send it a sig stop. And then pull a link. And you'll see that the LED stays green. And if you have a network admin background, you know that if you pull a link and the LED stays green, oh boy, it's time for a therapeutic reboot, right? Or maybe an RMA if you're feeling cranky with your vendor. But in our switch, maybe someone just, you know, maybe the LED process is just hung. And so you can sort of take the link in and out, and you know, nothing happens. Now, what's happening, of course, under the hood is that messages are accumulating in the socket buffer from the system database to the LED agent, link up, link down, link up, link down, and things are stuck there. Now, when you wait for 60 seconds, our process manager gets impatient with the LED agent, so it's not making any forward progress, and kills it. Now, at this point, you might be wondering to yourself, you said it was a state-oriented system. You said message passing was bad, but you're sending all those update messages around. Like, what are you talking about? It's right here that you can see the difference between a state-oriented system and a message passing system. Yes, we use messages as synchronized state, but it's state-oriented in the sense that the state is what matters, and it's illustrated right here. What do you think happens to that queue of update messages between sysdb and the LED agent when we kill the LED agent for being unresponsive? In a message passing system, you've got to be very careful. You need those messages to get the new LED agent into the correct state. But what do you think we do? Any guesses? Right. Throw them out. We don't care. They're in a socket buffer, socket closes, they go away. We don't need them. Because when the new LED agent starts, it does the same thing the LED agent always does when it starts. It gets an initial copy of its state from sysdb, it updates the LEDs accordingly, and then waits for updates. So that's the difference between a message passing system and a state-oriented system. And this foundation lets these processes run completely independently of each other. One stops, one starts, they don't care. It looks like things are just being a little slow, right? So once you have this foundation of a common Linux environment and a state-oriented system that preserves the state integrity of the overall system, you can open this up to third parties. And it was actually kind of funny. You know, we were doing so many things early at the company to make developing software for switches more fun. And we're really excited about it, right? It's like, oh my gosh, it's gonna be so much better because you can just write this code in this one agent, test it, unit test it on your Unix server, and then, you know. And I realized one day, why should we be the only ones doing it? Why not open this thing up and let anybody add their software to the box? And my friends were like, Ken, like, yeah, that sounds cool and all, but like, are you sure this is a good idea? Because people count on this thing running, right? They're gonna put stuff on there that doesn't work and the switch is gonna break. They're gonna blame us. I'm like, am I sure? Of course not. We're a startup. I gotta go for it and this kind of thing. So all right, leave the thing open, see what happens. So we've got an SDK. We actually wrote a vision statement for this. 10 years, we wanted to see networks working better because the switch runs the customer's software, right? So we created an SDK. You put your code in a shared library. It links against our shared library. You can run that off box or on box. Write the code C++, Python, or Go. The code looks kind of like this. This is a simple Python agent. This is a complete EOS SDK agent. It doesn't do very much. All it does is monitors all of the interfaces on the box. When the interfaces go up and down, it prints a little message saying the state of the interface. Do I have a pointer here? No, not really. All right, sorry, Webba. So it's, you know, the state of the interface is now up or down, counts the number of changes, and prints the number of changes. So it's a very simple program, but it illustrates the point. You're connected to the system database. You're state-oriented and getting the updates. And with this environment, some customers have done some pretty interesting things. Though, sorry, maybe this is a bit of an aside, but we used to sort of guess about who would be the early adopter for this. What kind of organization, what kind of person would be the first outside of, our software team to actually write code to run on the switch? Any guesses? Sorry? Google? Good guess. It's not Google. I thought maybe it would be. Go ahead. Competitors. That would be funny. I cannot tell you. I do not know what our competitors have added to our switch. I bet they've experimented though. Sorry. Yeah, the HFT cowboys, they would be a candidate, but they would only do it if they could lower latency somehow by adding software, since their top 3 priorities are latency, latency, and latency, as far as I can tell. I thought it would be college students. I thought the people doing kind of the open flow research or whatever would like to be able to go in there and hack up their own software, but I was wrong. It was actually our own sales engineers trying to close some last-minute customer objection about our switches. One of them, we landed one of the big financials, had the deal all in place. This is early, like 2009 or something. And at the 11th hour, Cisco figured out that our switches didn't support, wait for it, idle CLI session timeout, right? If no one types anything at the CLI, it's supposed to terminate the session after some number of minutes. This was an InfoSec requirement of the bank. And Cisco said, you guys can't buy this because it doesn't have that feature. Oh, so the customer calls us up and says, sorry, deal's dead. You guys don't have this feature. And the SE calls me, he's in tears, and like, just build it. It's like, what? You can do it through the SDK, right? So that weekend, he hacked up idle CLI session timeout, delivered it on that Monday, and they're, okay, great, we can do the deal. And Cisco, I mean, can you imagine? You've done your hard work, you did the homework, you figured out, you did the correct chop, and the Arista's down for the count. And the next thing you know, you're just standing in a 40-foot hole. Like, how did I get down here? So we picked out a magic wand of programmability and waved it in their general direction. And like, we're just playing a different game, right? So that was very, very fun. And SEs have continued to do that, just helping enhance the value of our solution to the customer by making very small changes, management automation, integration, deployment stuff, it's just been really, that part's been really fun to watch. But we also have some customer activity here as well. And this is where the 10-year vision was realized. It was one of the web scale companies that wanted to do some really interesting things with their egress peer engineering. The idea is that if you have, in the diagram here, we have 3 data centers. There's the, and they connect to various sort of, ISPs of various, and exchange points and, the Equinixes and things like that. And the web scale company runs their own sophisticated overlay software to kind of figure out for any IP prefix, what is the measurable best exit point? Like, forget what the metrics say. Like, what's the best way to get to grandma's house? Should I go to Orlando and go to Time Warner? Or should I go all the way to Fort Lauderdale and hand it off to, so they sort of figure that out, right? And build this huge table. It's like way bigger than the internet routing table itself. For every, because it's much more fine-grained, for every prefix, like, what's the best exit point? Then so the traffic originates from a server at point 1, and they actually load this into all the servers. So all the servers know the exit point. What the server does is it takes the IP frame to grandma, puts an MPLS label on it to indicate which exit interface should be used, then puts a GRE header on that to wrap the packet and send it to the exit point's IP address, which is in this case device 3. And then sends that frame through the network. So the frame routes across the provider's, the web company's own worldwide network across data centers as needed, until it gets to the correct exit switch, number 3, which decaps GRE, and then looks at the MPLS label and picks the next hop based on the MPLS label. So the switches never even look at the actual IP destination. This way they can have massive, sort of size tables, but switches that have small on silicon tables, right? So use lower cost switches. And part of the solution is the customer running their own software on the device at point 3 to build these mappings from MPLS label to IP next hop. And it was very gratifying, let's just say. So I would say that when it comes to putting your own software on a switch, not very many customers are going to do this. The ones who do, they buy a lot of switches. So it ends up working out pretty well. Here's another example. This is a public presentation from Comcast, where one of their distinguished engineers hacked up in lab. He was talking about, he was frustrated by how slow vendors were at bringing segment routing features onto their switches. So in his Nanog presentation, this is a slide from his presentation. He said, wouldn't it be great if we had an open platform today where you'd have sort of the ASICs underneath, the Linux kernel, and then put your own code next to the vendor's code to be able to experiment with your own ideas, unicorns and rainbows, right? Well, unicorns and rainbows are here. And he didn't put our name on this, which really annoys me. But this is our switch, and he added segment himself. Doesn't run RStack, runs Quagga instead. Quagga loads routes into the kernel just using netlink sockets. Our software responds, right? We implemented our software to try to be friendly to this kind of approach. So we have actually an agent on the switch that monitors netlink, and if some external force sticks routes into the kernel, we suck them out through the netlink socket in the system database, which then propagates them through the forwarding agent into the hardware. Right? It's pretty cool. You log into a switch and just do an IP route add, blah, 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 and the next thing you know, packets are hitting that route in hardware. So it's pretty neat. So he was able to get our switches doing segment routing about 2 years before we were. Another example here is from Spotify, which also is presented publicly on this, that they're able to use our switch to replace routers at their internet peering points by using SFlow to collect traffic profile data about which IP prefixes are the most used. It turns out that about 10% of your fib entries account for traffic, right? It's not really very surprising because there's huge route diversity out in the corners of the internet that you're not even, Spotify's not streaming to, right? So they can use SFlow to identify offline the 10% top prefixes and then use the programmability of our device to load just that 10% into the hardware. And if something misses in that 10% sort of route cache, if you want to call it that, they then default route it to like, an MX960 or whatever. But that means they can have a whole bunch of Aristas providing all the bandwidth with just one MX sort of handling the exceptions rather than having to buy a flock of MXs, which cost, I don't know, I'm not sure the exact multiple, 10 or 20 times as much per port, right? So this is another example of programmability really coming in handy for our customers. So the net result of all of this has been some pretty exciting progress on the business front, where the green bars here are revenue. We did over $1 billion of revenue last year. I sometimes pinch myself. I sometimes look around our office and our results, and I just can't believe it. This is a company that we started, 13 years ago. It's almost unimaginable that we've come this far. But then I think to myself, well, no, wait a minute. Was I planning to fail? Like, what would be the point of starting a company if you just thought it was this doomed from the beginning, right? So I can't quite square that circle. So I don't know. Anyway, so we've managed to be quite successful with all of this. Now so as our revenue has grown pretty quickly, but our headcount isn't growing so much. We're now almost $2 million per engineer, which is insane. The size of the opportunity that we have, the customer pull for switches that just work better is so strong. This market has been locked up by a couple of big players for so long, and customers are so frustrated. We have so much opportunity in this space, but it's a mature space. The competing devices have a ton of features and a ton of capabilities. Customers rely on them, right? So what we need is help get this all built. And so that's why I'm here today, to try to get you interested in potentially coming and helping us out. And so I was trying to think about well, where do I want to work, right? What matters to me? What I really like doing is working on interesting problems with smart people, have some real impact, learn some new stuff, and do that in a good work environment. Like, sure, I like getting paid also, that's good. But, so paying well is important. But really, those things are also, among all the jobs you can get, they all pay pretty well. These things seem to be what, at least for me, really sort of sets one opportunity apart from the others. And let me just go through these briefly. I mean, the networking space, I've been working in it a long time, since 1995 or so. And it's not getting any less interesting. It's only getting more interesting. The transition from sort of traditional enterprise data centers to cloud has sort of redefined the whole space of networking problems. The role of the big web companies in the public cloud, enterprises struggling with hybrid cloud, carriers trying to figure out how to be anything other than the world's dumbest pipes, right? So carriers are turning their networks from basically pipes for rent into content delivery networks, where every central office is turning into a small data center. And guess who switches on top of rack of one of the largest telecoms data centers, right? So there's so much interesting stuff going on in this space. And I hope we have smart people. I certainly think so. And real impact for sure. It's just really nice to be able to go home and tell my kids, where Netflix is sending the movies to Comcast. 7,500 on both sides. You know, that's what our products do, deliver this data. And you know, there's tons of stuff to learn. We work in every imaginable area here. And actually, this is sort of well, maybe I'll get to this later. There's a lot of flexibility within Arista for people to work on the projects that they find interesting. And then when it comes to the good work environment, that's where it comes to the culture of the company. What is culture? Culture is what's important to you. What are your values? What do you really care about? Why are you coming to work every day? What makes you proud or happy or satisfied to come to work? Your coworkers. How do people treat each other? What are kind of the norms and the rules and for things? And you know, earlier in my career, I didn't pay much attention to this. I would have been one of those guys. You know, you ask about a company, and it's like company value statement. Well, you know, you hired all those executives. They keep getting in the way. But you can send them to an offsite to write a value statement. Then you can get the work done. You know, some kind of reaction like that. But then I had the misfortune to work for a company that really needed better values. And I got to see firsthand the damage that you do when has kind of a us versus them attitude, inside circle with actual information. Oh, but don't tell the engineers because it would distract them, you know. And it's such BS. Anyway, so I got to live through that, and so that gave me much more of an appreciation for how important a good culture is and how it starts from the top of the organization. Like, there's nothing you can do if the people kind of running the show are a bunch of jerks. Like, it's just irretrievable. So I started Arista, determined to put the kind of work culture in place that I would really want to be a part of. So I actually wrote the company value statement. And there are 3 values I put on there, which number 1 is do the right thing. Oh, sorry, one side comment is that when I was writing the value statement, I circulated it among 2 groups of people. The other early guys, you know, at Arista, and also some of my friends from my previous company. And the difference in reaction was like palpable, because like guys at Arista were like, yeah, that sounds pretty good, Ken. Yeah, nice job. And the guys from my previous company are like, oh my God, I'm so glad you're doing this. And have you thought about, what about adding this? And are you sure that's really, you know, the level of engagement was very different. I think you have to really live through a bad culture to appreciate a better one. So anyway, the first value is do the right thing. And I mean do the right thing in 2 senses. First and foremost, I mean it in the ethical sense. One of the really gratifying things for me personally about my journey at Arista. So when I started off at the company, believe it or not, I was acting president of Arista. So I was running sales and whatever, in addition to, of course, we were mostly just building product, but I knew that in that role, I would have a lot of contact with customers and, you know, press and whatever. And I had a lot of sort of anxiety around that because I'm an engineer, right? I call it like I see it. And for engineering, that's fine. But, you know, to succeed in business, don't you, you're supposed to spin it, right? You got to have your angle. You got to kind of push the envelope and get people all jazzed up about what you got to kind of, you know, and that's kind of not me. So I was sort of worried about whether I would succeed in that role. But I was like, no, look, I just got to be myself, right? So I'll go in and talk to customers and just tell them, yeah, this part of our product works really well. This part's not done. That part, I wouldn't do it that way, you know, whatever. Like, just be really open about it. And I've been just amazed how often doing what's ethically the right thing winds up being best for your business in the long run. It's just, you don't have to do any of that stuff. It's not even helpful. I don't understand why people do it, quite frankly, or why this isn't more obvious to more people. So, I mean, do the right thing in the ethical sense. I believe in my heart that the path from where we are today to maximum long-term shareholder value, whatever you want to measure, has each of us doing the right thing every step along that path, meaning treating people with honesty and candor, talking about your real reasons for things, treating people with respect, just treating people the way you would like to be treated, and that will get us to the right place. I also mean do the right thing in the engineering sense, because if you don't have time to do it right, what makes you think you got time to do it over? Because that's the path you're putting yourself on. And I've just, over and over in my other companies, I kept seeing people mess this up because there's some schedule. The schedule says this be done by this time. So I'm looking at what I'm supposed to do, and I go to my boss and say, well, look, boss, you know, like, this module, I got to refactor. You know, the module isn't structured right to support the feature that I'm doing. He says, oh, yeah, Ken, that's right. But, you know, we're on a really tight schedule. Could you refactor that after we ship? What are you talking about? So it's stuff like that, right? So at Arista, the schedule is a planning tool. It's not the word of God, right? So we plan around a schedule, And then we do the projects, and as you do them, stuff comes up. There's a tool you need to fix. Your friend needs help with something. There's an escalation in the field. There's a big piece of work you didn't even realize had to be done, whatever it is. And so, things fall behind. What we ask from our developers is, look, please help us, help us know when this is happening so we can replan. We can ship with less. Maybe we can add people to the team. Or maybe we just need to go back to the customer and say, it's going to be 6 weeks delay or whatever it is. But that's what it's going to be. You've got schedule, you've got quality, you've got, there's only so many variables here, right? So the schedule is the thing that has to go. The second value is that collaboration is better than central control. That what we're doing is complicated. I've never actually run a fast food restaurant, but I imagine if you're running a fast food restaurant, you really can have the manager just say, hey, you go change the oil in the fryer later, you take the orders. That works pretty well. With software, forget it. It's complicated. You need each person to get the details of their project and their area into their heads and figure out the right way to do this and work together with others to make that happen. You can't have managers telling people what to do. So the third value is that each person has a unique contribution to make. And this means that we don't want to shoehorn people into narrow roles we've defined in the org chart, but we want people to make it as much a part of their job as they want to figure out how their interests and abilities best fit with the company's needs. And a lot of people, frankly, don't play a very active role there. They get involved in some area they kind of like, and project's winding up, and hey, boss, what's next? Oh, how about working on this thing? Okay, sure. Other people, just a minority, play a much more active role at steering themselves into the area that they're interested in working on. That door is a door that's open, but we ask our developers to take the initiative to walk through it. And there's some rare cases of people who really have gone beyond that and extended our product in dramatic ways based on their own initiative. Another aspect of this is that a lot of our competitors, they actually work pretty hard to keep engineers from talking to customers. And the sort of stated reason for that is, oh, you don't want to distract the engineers with this or waste their time and create confusion in the field and blah, 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 blah. I don't know what the real reason is. And maybe they believe that reason. Or it may be that the real reason is they like to lie to their customers, and engineers generally kind of tell the truth. And so then the customer finds out and gets pissed. And the only way to prevent that is to keep the engineer talking to the customer. I don't know. Whatever reason it is, we very much encourage engineers to talk to customers as much as they're willing and able, because the exchange both directions is beneficial on both sides. The customer gets a better understanding of how our product actually works and how they can take advantage of it. And the engineer gets to see what customers are actually bumping into, the things that actually matter for successful deployments. So, so we support people sort of reaching out beyond traditional organizational boundaries. Oh, and another aspect of this goes to project selection. Well, that's the right way to say this. So the alternative I've seen at other companies is suppose you're the manager. You're doing a new feature, and the new feature has a management plane component, a control plane component, a data path component. So okay, I've got to find a good data path person, find a good control plane person. I don't have anybody for the management plane. Well, let's see. When you look at the resumes, okay, this guy's got 6 years of SNMP experience, 11 years of SNMP experience. I'm going to go hire him. Well, this is not a very good approach for two reasons. The first is most talented engineers like to work on a variety of things. So if you filter for just someone who's worked on one thing for a very long time, you may not be getting the most curious and sort of energetic software engineer. But the bigger problem is that when you define the roles that way, you lock people into these boxes. You're responsible for this little piece, for that piece. That makes things easier as a manager, but it actually makes the software a lot harder because, it turns out the hard part isn't the SNMP. The hard part isn't the protocol. The hard part isn't loading ASIC registers, right? The hard part are the full system issues. What's the concurrency model? How does memory management work? What happens when we're under memory pressure? What happens if there's not adequate CPU? These sort of full system issues are really where all the hard problems are. And if you narrowly functionally define the roles, you're just begging for all those hard and interesting problems to fall right between the cracks of your functional organization and for the software to really suffer as a consequence. So we like to define roles much more broadly and have each person figure out for themselves where the edges are, where they're able to contribute. I've been monologuing here for quite a while. If there's any questions or comments, I really do welcome them. Okay. Some other aspects of the culture. Arista is a software company at its heart. Yes, we ship shiny metal boxes, but the engineering team is 10 to 1 software to hardware. We buy our ASICs off the shelf, so Broadcom, Intel, other makers. Our engineering focus is really on the software. And certainly I believe, and maybe I'm a bit of a nut, but I believe creating software is like fundamentally a fun thing to do. Like programming is it's just enjoyable. I program every day. I love programming. And it's fun if done right. And when you're finding that your job is a drag, someone's trying to tell you something. Someone's doing something wrong. To me, that's a real like wake up that it's not necessarily you, right? It can be aspects of the environment you're in, the tools, the processes have been defined, the behavior of other people. It can be complex to try to kind of unravel why you're faced with fixing 140,000 merge conflicts or looking at intermittent test failures and code that you don't know anything about. It's when you're getting tedious tasks, it's a good sign that someone's doing something wrong. And we've made that investment. So getting the right people, the right software architecture, getting the tooling set. So all the boring work. I mean, the thing about boring work in software is, in principle, there's no boring work in software. Because anything that's boring is generally boring because it's cut and dry. Anything that's cut and dry can be done by a computer, and making computers do things is fun. So any boring problem can be converted to a fun one, right? So that's the culture of software, I think, is central. We have that kind of appreciation. We build our entire management team. So back in the day, as I mentioned, I ran the whole company. It got to about 50 people, whereas literally everyone in the company is sort of reporting to me. Now, obviously, you're not really managing 50 people because that's not possible. But it was sort of, that was sort of the level where the chaos got high enough. I'm like, okay, I should probably have a manager. So some friends thought I should, say, hey, Ken, what you got to do is figure out who's got the technical skills and who's got the management skills. People with the technical skills, they go up this, nonsense ladder of engineer 1, 2, 3, 4, 5, tech lead 1, tech lead 2, distinguished engineer, principal engineer, fellow, right? People with the management skills go up the actual ladder, which is manager, senior manager, director, senior director, VP. It's like, all right, well, wait a minute. What are these management skills you're talking about? Because at the companies I've been at, the only management skill that really seemed valued was the ability, when the shit hit the fan, to deflect it as far across the organization as humanly possible. And this is the opposite of what I want people to do, because when we have problems, I'd like to figure out what we can learn from them. And you can't learn from your mistakes if people are afraid of being blamed. It doesn't work. So I don't want to do things that way. And so what I decided to do was look across my team and identify the top technical leaders. The kind of person where you have a question, so you know they're the experts, you go into their office, you ask them your question. They say, that's interesting, why are you asking me that? And you kind of explain some more context. They say, oh, I see. What if you, and they start suggesting things and you leave half an hour later with a better design, a better approach. They never answered your question because the fact you were asking it meant you were on the wrong path, and they detected that, right? So sort of that kind of person. And then from among those, maybe 2/3 or 3/4 of them also have that execution instinct. And what I mean by that is someone who just really cares about, they want to see their code ship, right? They don't just want to, they like solving hard problems, but they also want to really finish, get it shipped, get it tested, debugged, into a release vehicle, shipped, and if anything comes up in the field, what the heck is going on? I'll go figure that out. So that sort of execution instinct. I built the entire software management team out of people like that. All of our 55 managers now, and almost every single one was hired to write code, and did so, and wrote code, and contributed at that hands-on technical level for 1, 2, 3 years before we needed managers badly enough that I asked them to be a manager, and then they said no, they want to be a manager. Why not? Well, I was a manager at this other company, and let me tell you, it sucked. No, that's very different here. So try to explain. Well, one of them I had to ask literally 4 times over the course of 4 years. Look, you're already doing the job. He's like, really? Yeah, this is what we want you to do as a manager. It's like, oh, okay, fine, I'll do it. So we build our management team that way. What that means is that, because you see, people seem to, at other companies, they seem to behave as if the hard part or it's like the PowerPoints and the Microsoft project files and the people issues. That's just, basically very easy most of the time. That's a tiny, surely like a 5% of the job is dealing with that sort of thing. The hard part about managing software engineering is not the managing, it's the software. And when you have these managers who don't understand software, you get these insane behaviors like the VP who's saying, we got to ship in October. If we don't ship in October, I'm not going to get my big fat bonus. So how are we going to do it, guys? The software guys look at each other and say, there's no way to do this, boss. I'm sorry. And one of them pipes up and says, well, you know, we could fork the whole code base and hack out all the support for other platforms and sort of stick support for our platform and all the platform independent parts of the code. We could probably save 3 weeks. Like, the next thing you know, you've been put in charge of implementing your own sarcastic suggestion, right? And this is how it happens. I mean, I've watched this. This literally happened to me once at a previous job where I came into work one morning and all support for our platform was gone. Oh, it's off on this other branch now. You just cut and pasted 10,000 bugs. When are we going to merge that back together? It's so insane. So when you've got people who appreciate software in the sort of management positions, you just avoid doing all that kind of crazy stuff. Some more cultural points. Customer success is our success. We like to partner with our customers as deeply as we can, get involved with helping them design and run their networks. I've already mentioned that we ask engineers to just jump right on any quality issues in our software. Work-life balance matters. We founded this company 3 months after my first daughter was born. And I told the co-founders, guys, I'm going to work hard for this company, but I'm not missing my kid's childhood. Like, it's not worth it. And I've been working kind of 45, 50-hour weeks pretty much the whole way through. The whole myth of the Silicon Valley startup, I think, is just a big fantasy. People who are working 80, 90 hours a week, give me a break. That's no way to run your life. You're not going to be happy that way in the long term. If you're not happy, how are you going to do great work? It doesn't make any sense. So we support our employees at making work-life trade-offs that make their lives work for them. Judgment trumps process. We don't have very many formal processes in place, and the ones we do have, there are guidelines. There are no hard and fast rules. We want each person to do what makes sense. And if there's a guideline that you're going to violate, that should be kind of a signal that maybe you should think about why that guideline's in place. But if you understand why it's there and this doesn't apply in this case, just go do it, right? Like, these rules are here to try to make our lives easier, not just get in our way and slow us down. So we really avoid formal metrics. Like when it comes to performance evaluation, we don't make any use of formal metrics whatsoever because there's no judgment in them. Some other values, just do it, especially for new people. Joining a big company is kind of scary because you don't really know what the rules are. You don't want to break stuff. You don't want to piss people off. No, just get in and start doing things. The way great software gets written is by people writing it. So if you're going to go on and work in another area and do some stuff, it's nice to reach out, communicate, let the people know what you're doing. Maybe you'll get some good pointers, but there's no boundaries or silos or unwritten rules, and if you break them, you're going to get stepped on or anything like that. Code wins arguments. People like to reach consensus. When we can't reach consensus, he who's doing it gets to decide, right? And the way we do performance reviews. If you ask a lot of managers what they dislike the most about being a manager, instant answer, performance reviews. It's a nightmare. I was a manager at my previous company, and the CEO put in place the 37-point McKinsey performance evaluation process. I just wanted to cry. And you to evaluate each person on a scale of 1 to 5 on 37 different attributes. And it just made no sense. So we turned that around completely. And the fundamental problem with the standard performance review process is this manager-centricness. It's like the manager has this totally outsized voice, and then all the compensation decisions wind up to be sort of fighting between managers. Politics, how hard your boss is willing to fight for you, and that kind of thing. We put in place a full 360-degree performance review process. At the end of the day, yes, performance review is going to be by management discretion, but by far the most important input is a 360-degree review, where we get a rank list from each employee and use that to build an overall force rank of the entire department. And I don't know of an ideal way. If I had a magic wand, I could point to somebody and measure their contribution. Believe me, I'd use it. In the absence of that, I think gathering data from everyone who's worked with that person closely is the best surrogate I've got. So, and then finally, we have leaders, not managers. we value is not management of process and schedule and task tracking and all that sort of stuff, but leading, helping people see the better way to build something, help anticipate the difficulties, help people be more effective and feel better about what they're doing. Those are the attributes that we value in leadership. So our Dublin office here was a world-class development center. I have the same ambitions for this office that I have for each of Arista's offices, which is an independent, fully functioning software development center with end-to-end ownership of features, meaning everything from deciding what the feature is going to do in the long haul, to how is it broken down into phases, to what do we do in phase 1, to how is it technically going to work, technical design, implementation plan, doing the implementation, writing all the tests, getting it all debugged and working and merged into a release vehicle and shipped, and then supported in the field, end-to-end ownership for all of that. In every area of the product, we have no boundaries. It's not like this office works on routing and that office works on bridging, this other office works on the hardware platform. It's not that at all. We have teams in each of those areas in each of our offices. And part of the reason for that, by the way, is very practical, right? We have to support our products all times. Originally, all of our multicast work was done in Santa Clara. Multicast is mainly used by financial companies. They do their pre-flight checks at 6 a.m. Eastern time. And that's when they find problems. You get enough escalations at 4 a.m. and you're thinking, you know, it's 4:30 in Bangalore. Like, maybe we should have those guys learn the multicast stack. So, but the more important reason to avoid those kinds of barriers is because it gets a kind of cross-collaboration going on across offices that prevents the warfare, right? Because when you sort of shoot people into an area and say, this is your line, then when someone over here needs something from something over there, they can't get it, they can't just do it themselves because, well, that's not theirs. They don't have charter to edit that code, as if code is like some magic thing that if you don't, not in the right office, you couldn't possibly understand it. And then they sort of try to get these guys to do what they need, but they don't understand, they don't do it right, they slow them down, and it just becomes this warfare, right? And that just completely goes away when you have people in different offices sharing responsibility for the different areas of the product. So management plane, control plane, forwarding plane, we do it all in this office. 63 engineers, growing fast, and with your help, we'll be growing even faster. Any questions? Quality control. I have two rules for quality. First, get rid of QA. Second, get rid of regression test. Then you'll have better quality. So the way this works at Arista is quality is actually our product's most important attribute. Not one of the most important, it is the most important. It's more important than features. It's more important than platforms. It's more important than schedules. I'd rather apologize 100 times for missing a date than apologize even once for melting down somebody's network. We have agreement on this at every level of the company. Account managers, who they're under pressure, they got to get their quota met, right? And they need to close some deals, so they need all the latest features, they need it all yesterday. They tell me, yes, Ken, but never sacrifice quality. My customer relationship is more important to me than making my numbers. I'd rather apologize to my boss about the numbers, apologize to the customer saying we can't meet your needs, than melt down their network, right? So we're just unified across the country, across the company, that quality is most important. And that's actually one of the things I personally really like about working in the networking space, is that there are other domains where it's just not as important. Going fast, like, anybody know Facebook's engineering motto up through 2014? Run fast, break stuff. Yeah, that's exactly right. And that's a powerful statement, but not for us, right? I mean, for Facebook, that was almost certainly the right thing at that time. But for us, absolutely not. Maybe 10% of the customer's CapEx goes into the data center switches. But when the switches are down, the whole thing's 100% down, right? So there's a very high leverage there. So the way we do this is actually kind of funny too, because one of the sources of great frustration for me at a previous company was the difficulty in refactoring. Because you try to refactor something and then get told you can't do that. Why not? I'm working weekends and nights. It fits in the schedule. It's not the schedule. That's not the problem. You can't refactor that because that module you're refactoring is being used by 4 different features on 9 different hardware platforms. Tell me, Ken, you want to retest all yourself? Well, I can't retest it all myself, right? We've got a QA group. Aren't they going to test it? Well, you see, back when we first built that feature, yeah, we tested it real thorough, lots of tests and exhaustive combinations. But we weren't planning any major changes in that area for this release, so we thought we'd just do regression test. Regression test, that sounds good. What's that? Oh, well, you poke it with a stick, and it wiggles, you ship. And they don't quite say it that way, but that's what it boils down to. It boils down to this misunderstanding of software that if you only change it a little, you only need to test it a little. But it's not true. The wonderful and horrifying thing about software is a small change over here can have a big impact way over there. So unless you're making no changes at all, you ought to run every test case for every feature on every platform for every software release. But no one can do that, right? It's a practical impossibility. Well, sure, unless you start from day one demanding from your engineering team two things. One, the new feature. Two, a set of fully automated tests that proves the new feature works. And then it's just a matter of buying hardware. We've got over 1,000 test beds, 4.5 megawatts of data center capacity, running 24/7, running about 70,000 tests a day, so that we can validate that every feature works on every platform in all the cases. And so now, don't get me wrong here. We do have professional testers. So I started with this crazy idea. We wouldn't hire any testers at all. And then I realized that's not smart. Professional testers are great. They think of stuff, right? They try things, and they put the box through a kind of exercise that's actually very difficult to automate the tests for. And our testers love it because they're freed from the QA matrix, right? That's what the software tests do. The system test people come in every day and say, how should I break the switch today? And they hook up some crazy topology and take out a big hammer and go bong, 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 bong on the switch and flap the routes and flap the links, and it explodes in a fiery ball of flame. And then we take a look at how that happened, right? So you figure out, get the root cause, and then say, oh, I see, they can queue up there too. Then write a targeted test at the specific thing that went wrong. Because reproducing the test with a big hammer and all that, you just can't do it, really. I mean, you end up spending all your time debugging the test. Frustrating. So, yes? We have versions of Chaos Monkey. We have, for example, between every pair of tests, we kill an agent randomly selected to make sure the next test can then complete, even with that agent having just been assassinated, to make sure our agents are truly restartable. We do the same thing for supervisor switchovers, and but their Chaos Monkeys are not that creative. They do a certain number of things, but the system test people are way more creative than our software Chaos Monkeys. And so we then create a targeted test targeting the specific defect that was revealed through the crazy test, get that working, give the image back to system test, and then it explodes in a completely different way, and you iterate until it doesn't seem to explode anymore, then you ship, right? So, so I think that test automation is key. I should also mention that we have two classes of tests. We have unit tests that run as part of every build and validate the logical integrity of each agent in isolation. Then we have our product tests that run once the image is built against the actual hardware and on a fully integrated image with all the features all together. And that's important because there are corners you can drive into very easily in unit tests that are really hard to get into in a fully integrated product. Yes? Regressions, I'm not quite sure what you mean by regressions. I would certainly agree that customer code can cause interesting things to happen on your switch. Yeah, this was always a concern of people, but to this day, we don't have a single case of somebody adding code to our switch, causing a problem, and then blaming us for it. It doesn't happen. People who would be inclined to do that are generally with it enough to realize they probably shouldn't be adding code to the switch in the first place, right? The people who are adding the code to the switch, they get it. They're on a Linux system. They're writing Linux processes alongside ours. If they do things like fork bomb the switch, it's going to crash, right? They consume all the inodes in the tempfs. There's going to be problems, right? So our customers who are doing the kind of sophisticated extensions understand the nature of the system they're building within. And when they do break things, and they do, they first debug on their own. They get to the point where they think there's an issue with our software, and then they call us up and they talk to us about it. And we're happy to work with our customers in this regard. This is the kind of customer partnership we thrive on. So sometimes the problem's on our side, sometimes on their side, they just need our help to understand what's going on. But this is just a problem in practice. Yes. Yes. Oh, nothing deep like that. The question is about kernel extensions. We do have a certain number of patches in the kernel, things like jumbo frames on tap interfaces, things like TCP MD5 authentication across a subnet block rather than just associated with a certain address. We're currently we're doing some kind of interesting work with our containerized EOS, running EOS as a container on customers' systems. And we're hitting an issue there that some of our processes don't like it when they don't have the kernel extensions they're expecting. And in most cases, there's some cases where we really need the extensions. Like it's very hard to implement a correct PIM router with the Linux kernel multicast support. Like, it just doesn't it just doesn't work properly for PIM asserts, for example. So there, if you don't have the right kernel extensions, we're just gonna have to say you can't turn PIM on. But like you can certainly use BGP even if we're missing TCP MD5 auth for passive listen ranges, right? You can't use TCP MD5 auth with passive listen ranges. You can do everything else in BGP. We have some work to do to go through our software and just be more kernel tolerant, right? So like if we have the extension, great. If we don't have it, well, we fall back and do something. Also issues in Linux. If you have 2,300 network interfaces, control plane protocol demultiplexing gets very cumbersome in Linux because you got to create a separate socket for every interface and bind it. And so we kind of hacked that. We've had our own address families, one socket, and just get all the protocol frames at once. If you don't have that kernel extension, there's no reason you can't bind a socket to every interface in a box with a small number of interfaces. Most of the places where people want to run their own kernel, it's not our big modular box with 2,300 interfaces, right? So we're sort of wrestling with that issue. We make all of our patches available, so you certainly can rebuild our kernel, and then you can do whatever you want with our patches.
And what about user space? Things like the libc and everything. Are you basing that on top of some distribution? Are you starting from scratch with every basic package?
The question is, what Linux user space do we use? It's a Fedora 18 user space. It's a little long in the tooth. We're upgrading it. We're kind of in the beginning of an upgrade cycle for that. Everything's there. All the standard libraries are there. Standard tools are there. You go to a shell, run ping, traceroute, fping, MRT. You know, all that stuff is right there on the box. Yes.
You mentioned that you have quite extensive test infrastructure.
Yes.
If I'm to make a small change, how much?
The question is, how much testing do you have to do for a small change to the software? So the way this works is we have a system that looks at what files and lines you changed and selects tests for you. It asks you to think about what other tests would be useful. Because we'll go to a test schedule that runs concurrently across all 1,000 test beds, right? So sometimes it gets a little backed up and it can take several hours. Usually it takes maybe 2 or 3 hours to have your test results back. At that point, your merge unit is qualified to merge to trunk. Usually the tests run, because to be qualified to merge a merge unit to trunk, so we use a continuous integration process. So everybody develops right into trunk. Interesting 750 engineers, you know. And to make that work, we have to do this testing, obviously. So your merge unit has to be qualified both by running the tests, but also through a code review. Usually the code review is the gating factor, not the tests themselves. So it ends up working out, I think, pretty well in those cases. No, so the way this works is you prepare a merge unit, you submit it to your branch, then you launch, and then it sets off in parallel an auto build, auto test, and code review. And the auto build has to happen before the auto test because you can't test the image until it's built. But the code review is asynchronous with respect to the. Yes.
Have you ever thought about security? I mean, it's not that fresh and red. Nothing makes it city. And the red looks really pretty. See? Right, Ronnie, Jack. Okay. Here are the rolls and the scrolls. Oh, rolls and scrolls? Those words rhyme too. Scrolls and rolls do rhyme. We could be the bakers who make bread and rhyme at the same time. Rhyme and baking. I love it.
The question is what about the security? You're using this open source software, it's full of bugs, aren't you, full of vulnerabilities? Well, the reality here is that we, different boundaries between what and what? The company and the system? Components of the system, whether it's separate address spaces. They all run as root. So
We bakers love to run.
Hi, bakers.
Yeah, have a bun. A bun is fun. You could eat
yeah, they're all running as root basically. Yeah, there's no user security really on the box.
Fun, son. Done. Great robbing, bakers. Bye.
Hi, Diane. What would you like from the running bakers today? Oh, you know what's so good?
Sure. I understand the question. So so first of all, 90% of the processes are doing things like managing ASIC tables or providing, internal functions. They're not listening on the network at all. So it's not very easy for them to have an exploitable buffer overrun. Most of the software that is actually very well beaten on software. So using standard Linux, NTP or syslogd or things like that. This is software being run on millions of Linux servers all over the internet. So it's been pretty well combed over. Certainly in principle, there can be security vulnerabilities there. We do auditing and testing. We have people who are combing through the code. We did find one bad security vulnerability in our audits, and we've obviously fixed that. We've qualified for the various intelligence service deployments. We're deployed by multiple intelligence services across the world who have fairly demanding security requirements, obviously, as well as financial guys. So I think that in terms of your exposure, I think you're much better off with our box than you are with a box where it's all closed source, where the black hats have the code and the white hats don't, right? So is it perfect? No, it's not. But compared to anyone else in the industry, you're better off with what we've got. No one prevents us from writing what?
Nobody prevents you from adding user-level security complaints.
Yeah, so the comment is from deploying SE Linux. That's certainly true. We haven't seen fit to do that. I think the issue there is that well, maybe we should provide better isolation or better security containment. I think we're really trying to keep people out of our processes to begin with, rather than focusing on what they can do once they get control of one. But if you look at it from the point of view, because how is someone going to get in, right? They're going to get in through something like, say, BGP. There's some routing. It's got to be some process actually listening on the network, right? They can't possibly break in through the ASIC driver. It's not possible. It doesn't receive control frames, right? So they're going to break in through something that listens to the network. Let's say it's BGP. So if you can break into BGP, imagine you're contained there. You have control of routing. Right? What more do you need? My point is that it's not really clear that you're changing your customer's risk profile very much. You certainly make things more complicated by introducing SE Linux sort of boundaries. No one's asked us to do that so far among our security conscious customers. We'd be open to doing that. Of course we would. If we thought there was a security benefit to that, we certainly could do that. But we so far haven't seen fit to do that.
That dog is lying down.
Yes.
Bingo. That dog is walking. I'll just put the walking dog with the person who is walking.
For most customers, we package the software as a software image file. The whole image is updated at once. Customers tend to prefer that because it's what they're used to. Also, it's the way they get confidence that the software that's running is sort of a coherent set of software that's tested and supported by us, right? But we absolutely support people updating packages piecemeal. And in fact, for security vulnerabilities, for shell shock and heartbleed, we deployed RPMs to our customers that they install with our extension manager and can patch a live system that way. Zero downtime. We had 3 pages of instructions because we have one image that runs on all of our products. It was pretty funny to look at the difference and look at the shell shock instructions from Arista compared to the instructions from our competitors. We have 3 pages. Here's an RPM, stick it on the switch, you're done. They're 230 pages of every platform and operating system. Replace this image with that image, and this image with that image, and this image with that image, and it's all full reboots, and it's just oh my gosh. So we're in a much, much better shape. Yes?
Whoa. Check it out. Got a rectangle shape with a nice bright yellow background. And a picture of my favorite dinosaur, a Tyrannosaurus Rex.
We have a mole here who's asking if we've changed our development model from a per feature branch-based development model to a continuous integration into a shared trunk model. And the answer is yes. That was my mission for 2016, was pulling the entire development team to CI. And we no longer have any of those branches. So if you merge the Jericho Plus branch or the Trident 2 Plus branch, yeah, we don't do that anymore. And my God, it's such a huge improvement. Yes.
My dog Everybody ready?
All right. Well, my goodness, okay. Question is whether customer extensions of container or they just run as like root alongside everything else. And the answer is, what does the customer want to do? It's completely up to the customer. We have Docker on the switch. You can download containers onto the switch and run them. You can set up C groups if you want. You can run with whatever UID you feel like running with. You've got a root shell. You know, you do what you want with it. So if the customer, what we recommend people do is basically don't worry about it except for memory. It's not fun to run out of memory on the switch. The killer gets pretty excited pretty easily, starts killing things. Like the early days, the killer, we didn't tune it, and it would sort of look around and it would always pick the same process every time, the system database. It's like, why don't you save some trouble and just kill the kernel itself, you know? So we had to do some tuning, but now it's pretty good about sort of killing off management plane stuff first and trying to keep the network, you know, actually working. But we do recommend that people get into some kind of isolation mechanism for their respect to memory. So you just set R limit is enough, right? It's like just you limit your process and keep it from, you know, allocating all memory, and you're probably fine. Or you can use C groups or whatever, or containers. And containers just use C groups, obviously. Yes.
So it looks like you do very open source content on that.
Thank you.
Can I go home and run POS in my machine and try to hack things?
Oh, so EOS is not, the question is, can I just take EOS and run it on my own just for fun in my spare time? And the answer is, yes, you can. It's not fully open source. There's plenty of source code that we keep to ourselves, thank you very much. But there are a lot of open source components, and of course we comply with the relevant licenses and provide the source code for our changes. But also, we provide a VEOS lab, which is a VM image. It's got very limited data path, but you can certainly run EOS. You can get your shell, you can mess around, install your software, set up the control plane, connect two of them together, have them exchange routes. All that sort of stuff works with the VEOS lab. It's just a VMDK that you can run under. You can run under, you know, QEMU KVM, or you can run it under VMware or blinking the Macintosh, whatever it's called, VirtualBox. There we go. All right. Well, why don't we call it there? Thank you so much. And I'm happy to take other questions up here. Just come say hello. All right. Thank you so much for coming. Thank you.
Now for the cream. We're going to whip it till it's fluffy. Ginger blue strawberries. My name is Diane, and I'm a chef. And they say I'm super sweet. I'm the happiest in the kitchen when I'm doing things.